So this next video is going to be on factorizing when a is equal to 1. And what I mean by a equals 1 is as follows. So we remember the standard form for a quadratic is ax squared plus bx plus c. And in this case, we're looking at only particular cases where a is equal to 1. So in other words, you can see with all the examples that I've given that the coefficient of the squared term is always just 1 in this case. So how do we factorize in this sense? Two things we have to remember, and that we have to look at two particular things. What two numbers, so you need to keep in your mind what two numbers multiply to give the last term, but add up to give that middle term, including the sign. So if I was going to ask you what two numbers would add up to give 5 but multiply to give 6, what two numbers would do that? If we look at 2 and 3 in this case, what we would have is 2 times 3, so 2 times 3 equals 6, but 2 plus 3 equals 5. So this is what we should be implementing in the particular examples, as we'll see. So example 1 says x squared plus 8x plus 7. So we should be working out two numbers that multiply to give 7, but add to give positive 8. So a good way I like to do this is first, I'm just going to rewrite this here because it seems like that it's a bit squishy over there. I like to come up with all the pair factors of 7. And by pair factors I mean not just 7 by itself and not just, for example, 1 by itself, but 7 times 1. And in this case, what's another factor of 7? Minus 7 and minus 1. And then what I'm going to do is I'm going to add these. So 7 plus 1 is 8, but minus 7 minus 1 is minus 8. So in this case, which one gives us this factor? It's going to be this set of numbers. So it's going to be 7 and 1. So when we put these into brackets, we write this as x plus 7, x plus 1. Now the reason why it's plus is because these numbers are positive. If it was this particular example, I'm going to draw in green because it's not related to this question. This would be x minus 7 and x minus 1. But since it's not related to the question, don't worry about that so much. Let's look at the next one. So we have, we need to find two numbers that multiply to give 10, but add to give minus 11. So 10 and minus 11. So what I'm going to do is I'm going to just take my last number, so I'm going to drag this number across. I'm going to find all the pair factors of 10. And by pair factors I mean, for example, 10, 1, 2, 5, and I'm going to look at minus 10, minus 1, minus 2, and minus 5. So I'm going to have a look now which one gives me minus 11. So 10 and 1, that gives me 11. 2 and 5, that gives me 7. Minus 10 and minus 11, that gives me minus 11. And minus 2 and minus 5, that gives me minus 7. So which one gives me minus 11? This one right here gives me minus 11. So the way this reduced to the brackets would be x minus 10, x minus 1. Next example, x squared plus x minus 90. So I'm going to find two numbers that multiply to give minus 90, but one number, so two numbers that add up to give positive 1. So I'm going to write out my pair factors for 90. So my pair factors for minus 90, are 45 and minus 2. So we've got minus 2 and 45. What we have is also 15 and minus 4, and we've got minus 15 and 4. We've also got 30 and minus 3, minus 30 and 3. And well, I'm just going to jump the gun a bit here because otherwise we're going to come up with a lot of factors of 90. You kind of just have to use your intuition in this case, so I'm just going to jump on to 9 and minus 10 and minus 9 and 10. So if we have a look at all these pair factors now, let's add them up. So I'm just going to change color pen. It's going to get messy over here. This will become 43, and this is minus 43. So these are not the factors that you want because we want positive 1. 15 and 4, this is 11, and this will be minus 11. Nope, that's not the factors. 30 and minus 3, that's 27. The other one will be minus 27. And this one, in this case, will be minus 1, and this one will be positive 1. So the factors that we want are this one right here, because you can see that we have positive 1 in our question, and the other one's just a minus 1. So this reduces down to x minus 9, x plus 10. Okay, and the final question, once again, same thing. Factors, pair factors of 40. We've got pair factors of 40. The reason for that is we want to find two numbers that multiply to give 40 but add up to give minus 13. So pair factors of 40 are 4, 10, minus 4, minus 10. There's 8 and there's 5, and there's minus 8 and there's minus 5. Minus 5 right here. So I'm just going to stop right there because I know the answer is one of them. Try not to spend too much time writing down all the factors if you've got some sort of intuition. So for example, I wouldn't have put down 40 and 1 because 40 and 1, there's just too much of a gap between these two, because 40 plus 1 is 41. It can't be the factor of this. So 40 plus 10, we get 14. This one's minus 14. This one is 13, and this one's minus 13. So the factors that we want are in fact this one right here. So this will be n minus 8, n minus 5. Okay, so in the next video what we're going to be having a look at is factorizing when a is not 1. So when we have like for example 2x squared in the front, or 3x squared, or different numbers at the front.